Hi, welcome back to the topic 2 of module 6 of design of machine elements. Our today's learning objectives are to define a few terms related to cyclic design and why we need to design for these cyclic loads and what is mean by SN curve and how we are going to use it and how to estimate endurance limit for infinite life. These are all our learning objectives today. Fluctuating stresses. Here you can see three kind of graphs. In our first graph we will consider this one. First. Here the load varies from positive to negative for same value. These kind of stresses are called reversed stresses, and if stresses is varying to a certain value and then coming back to zero and then it's going to the same value, if it is so, those kind of stresses are called repeated stresses. And if a stress variation is not coming under these two category, then it is called fluctuating stress. Here the stress need not come to zero or negative value of all those things. Emphatic failure. Time delayed fracture under cyclic loading is called fatigue failure. This cyclic loading actually reduces our strength. You can consider a stick. If you are pulling and trying to break it, it may be difficult. But after bending for a few times, you can break it easily. This is due to reduction in the strength. Actually, cyclic loading reduces our strength. And importance of fatigue failure. Almost 80% of the mechanical components fails in fatigue. So, designing for fatigue failure is an important criteria. Endurance limit. Actually, uh, just before I told, cyclic loads reduces our strength, but that's not always true. If you are applying cyclic load up to 10 power 6 cycles, then the reduction in strength will not be there. You can see from this graph. Initially, the strength is reducing. Once the number of cycle is 10 power 6, then there will not be any uh, strength reduction. This limit, this constant strength is called endurance limit. Fatigue life. Number of cycles that the standard specimen can complete during the test before the appearance of the first crack is called fatigue life. We will take a standard specimen and test it in a bending machine by applying cyclic loads. When we are seeing the first fatigue crack, before that time the cycle remains, now that's called fatigue life. SN curve. What is SN curve and how we are going to use it, that we will be seeing in our module 8. Notch sensitivity. Actually, notch sensitivity factor Q can be defined as increase of actual stress over nominal stress divided by increase of theoretical stress over nominal stress. We will see this while we are solving the problem. Now, as of now, you just know this one. This is a ratio between increase of actual stress over nominal stress and increase of theoretical stress over nominal stress. And endurance limit estimation. Before a few slides, we saw that a graph showing stress versus number of cycles like this. This is stress, and in this axis, number of cycles. Here you saw a graph like this. This is 10 power 6, like that we saw that, but this value is there, na stress at this location. that is reduced strength. This is called endurance limit. We are going to refer this as sigma E. Okay, how to find this sigma E? By multiplying all these values, we will be getting endurance limit Ka, Kb, Kc, Kd and Ke dash. Ka is surface finish factor. From where to find? From PSG design data book 7.17. Kb is size factor, Kc is reliability factor and Kd is modifying factor for stress concentration. This Kd value is also we are going to refer in PSG design data book from the page numbers 7.7 to 7.17. The size and reliability factor we will be seeing here itself. This is surface finish factor. For a particular kind of surface finish, in our problem they will giving us the strength. We will compare the strength value and the surface finish given, and by matching it we will be getting the Ka value, and then Kb we will be taking out from this table, and then reliability factor value we will be getting from this table, and then modifying factor for stress concentration. This value is actually known as Kd. That Kd is equal to 1 by Kf. That Kf equal to 1 plus Q into Kt minus 1. This is available in PSG design data book page number 7.8, and this Q value is called knot sensitivity factor, that we can get it from this graph if they are not given in the sum, and this Kt value we can find it from page number 7.9 to 7.17. By substituting all these factors we can estimate the endurance limit. Then one more term sigma E dash was there. This is called modified endurance limit. That how we can find? By multiplying some constant for particular material we can find the uh, sigma E dash value. In case of steels, our ultimate strength can be multiplied by 0.5 to get the sigma E dash. This is not a derived one, this is a tested one. Before a few slides we saw a bending testing specimen to apply cyclic loads. For from various tests we found out this relation between ultimate strength and endurance limit sigma E dash. For like that we have got for various materials, and for our designing purpose we are going to use this first value only, that is sigma E dash equal to 0.5 into sigma ultimate. We will solve an example problem in our next live class, so for get a better understanding. Thank you.